The quadratic formula. Not every quadratic equation can be solved using factoring, and we've seen a procedure called completing the square. There are times when you would prefer to use a different procedure called using the quadratic formula. The quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is assuming we have a quadratic equation in standard form, ax squared plus bx plus c equals 0, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So whenever you are going to use the quadratic formula, put equations in standard form first. That includes getting 0 on one side by itself. There's part of the quadratic equation that is underneath the radical, the b squared minus 4ac, that has a special name. It's called the discriminant. And it helps us determine how many solutions a quadratic equation has. If the discriminant b squared minus 4ac is greater than 0 or positive, it will have two real solutions. If the discriminant equals 0, the equation will have one real solution. And if the discriminant is less than 0 or negative, the quadratic equation will have 0 real solutions. That doesn't mean it won't have any solutions, it just will have 0 or no real solutions. We will shortly learn in the next chapter that we will have two complex solutions, and we will be learning about complex numbers soon. Let's look at some examples. So our first example is 3x squared minus 2x plus 1 equals 0. So I'm going to first identify a, b, and c. And this is not a necessary step of the process, but until you're familiar using and have practiced using the quadratic formula for a while, it would probably be good practice for you to do so as well. Here a is 3, b is negative 2, and c is 1. Remember, we have the equation in standard form. We have 0 on one side by itself. Let's plug a, b, and c into the quadratic formula. So x is equal to the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 3 times 1 all over 2 times 3. Let's simplify. X is equal to positive 2 plus or minus negative 2 squared is 4. 4 times 3 times 1 is 12, so we have the square root of 4 minus 12 all over 2 times 3 is 6. Simplifying further, x is equal to 2 plus or minus the square root of negative 8 over 6. And you'll notice that the discriminant, the part underneath the radical, is negative 8. It's less than 0, so this quadratic equation has no real solution. A second example. 5x squared minus 6x plus 1 equals 0. A is 5, b is negative 6, c is 1. X is equal to the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 5 times 1 all over 2 times 5. Or x is equal to 6 plus or minus the square root of negative 6 squared is 36, minus 4 times 5 times 1 is 20, all over 2 times 5 is 10. Simplifying further, x is equal to 6 plus or minus the square root of 16 over 10. Okay, the discriminant is positive, so we are going to have two real solutions. We can take the square root of 16, and that's 4, so x is equal to 6 plus or minus 4 over 10. Because we no longer have a radical, we can actually calculate both of these individual solutions. The first one is when we have 6 plus 4 over 10, which is 10 over 10, or 1. We can also look at the solution, which is 6 minus 4 over 10, which is 2 over 10, or 1/5. So our solution to this quadratic equation, we've got two solutions, two real solutions, 1 or 1/5. Let's look at a third example. X squared plus 4x minus 4 equals 0. A is 1, B is 4, C is -4. X is equal to the opposite of 4 plus or minus the square root of 4 squared minus 4 times 1 times -4 all over 2 times 1. Simplifying, we have x equals -4 plus or minus the square root of 16, and then minus 4 times 1 times -4, we end up with plus 16 all over 2 times 1, which is 2. Simplifying further, we have -4 plus or minus the square root of 32 over 2. Okay, our discriminant is positive. We are going to have two real solutions. Let's simplify this radical. What's the largest perfect square factor of 32? 16. So I can rewrite this as the square root of 16 times 2, or the square root of 16 times the square root of 2, or 4 radical 2. So simplifying the solution further, we get x is equal to -4 plus or minus 4 radical 2 all over 2. To continue simplifying, it's easier to split this fraction into two separate fractions. So x equals -4 over 2 plus or minus 4 radical 2 over 2. Now simplify both fractions. X equals -2 plus or minus 2 radical 2. So these are our two real solutions. We can also have these in decimal form, and they would be -4.83 or 0.828. Those are our two decimal forms.